Hello and welcome to another Algebra 1 class with Mr. Graves. Today we're going to talk about simplified radicals. We just started in a unit on radicals and I want to share with you how we will simplify them. I also want to mention to you that in mathematics, from being really preschool all the way up through advanced mathematics, there are certain ways that we write and there are certain methods we use. An example, 2/4 is a fraction that we wouldn't necessarily write that as an answer. Doesn't mean it's not the right answer, but it's not simplified in the way that we would expect things to be simplified. And in mathematics, there's a real orderliness about what it is that we do and how we do things. And so we wouldn't write that as 2/4, we would reduce it and put it as 1/2. Well, radicals are the same, and let me take a look and have you look actually at the first example we have here. This is the square root of 24. We could say that, the square root of 24 is the square root of 24, but it's not necessarily in its simplest form. And we want it to be that way. So much like we wouldn't leave something as 2/4, we're not going to leave this as a square root of 24. And I'm going to show you how to simplify that. It's fairly easy to do, but something that I want you to understand. We'll first of all take 24, and what we'll do is we're going to break it down in the product of primes, and we will notice that the square root of 24 is 2 times 2 times 2 times 3. So what I'm going to do is every number, I'm going to break it down, and then from there, I'm going to go ahead and put all of the numbers under the radical sign. Now that's not necessarily a step that you'll need to do all of the time, but for us starting out, the concept and learning it, that's what we're going to do for now. And it will help you to maybe just see some things. Now, when you square root something, when you have a square root, we all know that the number up here is an automatic 2. But when we write square roots, we don't always write a 2. We just need to remember mentally that it's always a 2. Well, here's how we actually simplify the factors that are under this radical sign. All right, here's how we do it. This 2 lets us know the number that is in a set that can be pulled out. So here's what I'm looking for. I'm looking for sets of 2 of the same number under the radical sign. Okay? Well, I see that there's 3 2's here, but because I have a 2 here, I can only pull out one group of 2's. Okay? So if I have 3, I'll pull 3 out. We'll do that here in a minute. Okay? But this number lets me know how many sets of the 2's I can pull out. Well, these 2, and I want you to remember this phrase, the 2 actually become 1. Okay? So that means if I pull this set of 2's out of there, it actually becomes 1, 2. Okay? Not 2, but 1. What's left over inside is 2 times 3. We will not leave those separated. What we'll do is we'll put the square root, or 2 times the square root of 6. So actually what we've done is we have taken the square root of 24 and we have simplified it to what it should be. And the square root of 24 is 2 times the square root of 6. And that's how we do that. This 2 and this 3, they didn't have another number that was next to them that was the same. So because of that, we can't pull them out. We only pull out sets of 2 because this is a 2. All right? We'll pull out sets of 3 when we get to this problem. All right? Let's try 75. We'll break that down in the product of prime factors, and that's going to be a 3, and then a 25, 5, and then a 5. So what we have is 3 times 5 times 5. And it looks as though, because it's a square root, what are we looking for? Sets of 2 of the same number. And we have that in 5. We see 2 5's here. Circle, we're going to bring it out. All right, and what do we have? We have 5 times the square root of 3. And that's our simplified version of what the square root of 75 is. All right, let's take a look at square root of 40. All right, we'll break that down. We get 2 and then break it down to 20 and go 2 again, and then 2 and then 5. So the square root of 40 is 2, 2, 2, and 5. All right, but in these particular problems, we look for sets of 2 numbers. All right, well in this particular one, because it's a cube root, we look for sets of 3. And we know that we've got 3 2's here. When it comes out, again, the 3 will become 1, or the 2 will become 1, or the 4 will become 1 if it's a fourth root, and all the 2's become 1, 2. So 2 square root of 5, and that's our answer. The 5's left, it's alone, there was not another 5 that was with it, all right? I did these on the board already to save time in the videos. What we did is we just took two big numbers, and we wanted to find the square root of 648 and the cube root of 14,580. So here's what we did. We took 648, we broke it down in the product of primes. We were able to go 2 with the prime number 2 3 times, and then the rest were 3's, okay? When we simplified it, we ended up getting 3 2's and 4 3's. We'll take a look at what we can do here. This particular set, and this is squared, so it's sets of 2. There's a 2, all right, but we've got 1 2 left over that's got to stay. Here's a 3, here's a 3. So this 2 comes out as a 2, this 3 comes out as a 3, this set comes out as a 3, and what are we left with? We're left with a 2. 3 times 3 is 9, times 2 is 18. 18 square root 2 left over is our answer. There you go. Let's take 14,580, the cube root of it. We went 2 only twice, and then we went 3 all the way down. 5 is what we ended up with. We wrote it out here. Well, it's sets of 3. The 3 shall become 1, not 2. So let's make sure we remember that. Well, we only have 2 2's here, so that's going to have to stay. Here's a set of 3, and that's going to come out. Here's a set of 3, that's going to come out. So what do we have? 3 times 3 is 9. Square root, what's left over? 2 times 2 is 4, times 5 is 20. So 9 square root 20, and that's actually the cube root, 9 cube root 20. Remember, sets of 3, that's all we can do. All right? Let's take a look here. These two top problems on the board, as you get some more experience with radicals and all that, you might notice that there are factors. While we can also take this 32 and break it all the way down, we also can do this, all right? 32 is actually 16 times 2, all right? Now, what I'm going to do is I'm going to put all of the perfect squares on the left. I'm going to put stuff that is going to have to remain under the radical on the right. But we know that 16 is a perfect square, so that's kind of the beauty of that. We look at x to the third, and remember, we're looking for only sets of 2. So the square root of x squared, but remember we have another x, so let's just put that over here, okay? And then, move that over just a little, y squared also is going to be pulled out of there. So here's what we have. Square root of 16 is 4. X squared is x times x. Remember, these are all 2's, okay? And so what we can do there, I'm going to write that out because it'll get confusing. The x comes out as 1x. The y squared comes, x squared comes out as 1x. Y squared comes out as 1y. And then what are we left with? We have a 2 and an x. The 2 was left over. The x was left over because we had 3, but we only needed 2 to pull out to be 1, which is right here. So this becomes our official simplified answer of the square root of 32x to the third y squared. Okay? And we did it that way just because we saw a 32 there that could be broken down to 16 times 2. We'll take a look at this next one. We have a 16, and believe it or not, this is a cube root. Well, what is 16? Well, 16 is 8 times 2, all right? And we broke that apart. Remember, we can do that 8 times 2 using our product property of radicals, all right? Well, we have an x squared, don't we? Well, an x squared isn't going to help me because I need 3 x's. So I'm going to go to the right with that. Y to the fourth, look at that. I've got y, I can take 3 of them, all right? And I'm going to leave myself a y here, okay? Z to the sixth, okay? It looks as though I've got 2z to the thirds that I can use. Let me move this over a little bit so we can squeeze it in. 3 to the square root of 8, and then 3y to the third, and then we have 2z to the thirds So 8, cube root of 8, 2. We can pull out 1y there. We can pull out 1z there. All right, and we can pull out 1z there. So we've actually got 2 z's to make that z squared. Okay? Well, what's left over? Here was our dividing line, remember? These were all of the, probably put that dividing line on the other side of that 3. These were all of what was left over that could not be pulled out. So we're going to write ourselves a cube root of 2x squared y. And there is our answer, okay? Seems a little complicated, but it's not necessarily. We just ended up looking at each one, taking what we knew would work and get pulled out and put it to one side, and on the other side we would put the leftovers. So like a y to the 4th, remember? We need 3 to pull out just 1, which leaves us just 1, which is going to stay under the radical, okay? Here's a couple problems as well, and just remember that some of these terms, they actually, binomials actually work as terms. You know, we would, if we had x squared, and it was the square root of x, remember? We'd have an x times an x. Well, 2, what happens? They become 1, and there's nothing left. So x squared, all right, square root of x squared is equal to x. So the cube root of x plus 2 cubed is going to simply equal 1. X plus 2 in the same way, all right? What would the square root of x plus 2 be? Well, we can pull out 2. There's a square of 2 there. 2 is our root, so our answer would be x plus 2, all right? So to simplify a radical, just make sure that you break it down in the product of primes, find out what your root is, make sure that you pull out only the sets of the numbers that you have here. And then they become 1. Whatever's left over stays under the radical and has to stay there, and then you write it simplified, all right? I trust that's a help to you. I hope that you have a good day now. Thank you. Take care.